talk about the Pythagoras theorem. Okay, so I have here that it's a theorem that describes the relationship between the sides of a right angled triangle. So what this means is that the Pythagoras theorem only applies when you have the right angled triangle. Okay, so let's take a look at how the right angled triangle looks like. Remember, what I have here is not drawn to scale. Okay. There's A, B, C. Alright. So this is how a right angled triangle looks like. It has a long side. Okay. A long side which is called the hypotenuse. The hypotenuse. So take note of that. Alright. So the longer side here is denoted by C. Okay. And then it also has a right angle. This is how we denote the right angle. And you can see from the diagram that the right angle is opposite to the hypotenuse, which is the longest side. So Pythagoras is saying that if you have a right angle triangle, then this identity holds. You can write that C squared is equal to H squared plus what? Plus B squared. Okay, so Pythagoras is saying that the square of the hypotenuse is equal to the sum of square of the two other sides. Okay, so you have to keep this identity in mind because we're going to use it to calculate some examples or some problems. Is that okay? Alright, so let's make progress. So I want us to take an example and see how we can apply the Pythagoras theorem to find the missing sides. Okay, so we have this right angle triangle. Again, it's not drawn to scale. The hypotenuse to be x. And then here it's 4, and then here is 3. You're supposed to find, find x, which is the hypotenuse. So quickly, since this is a right angle triangle, then we are going to apply the Pythagoras theorem to solve the missing side. Okay, so from Pythagoras we can say that what x squared is equal to 4 squared plus 3 squared. Is that also? Alright, so this s squared will be equal to 4 squared is 16 plus 3 squared is 9. So my s squared is equal to 16 plus 9 is 25. So my x is going to be equal to what? The square root of 25. And that is what? That is 5. Is that okay? Alright, so let's take another example. So where we have this right angle triangle, the hypotenuse to be y, and the other two sides to be 5 and 13. Okay, I'm supposed to find. So again, I'm supposed to find what? Find y. Okay, so quickly, since this is a right angle triangle, then we apply what's the Pythagoras theorem. So from Pythagoras, we can say that y squared is equal to 5 squared plus 13 squared. So the y squared is equal to this 5 squared is 25 plus 13 squared is 169. So my y squared is going to give, if I add 25 plus 169, then I'm going to have 194. So my y is going to be the square root of 194, which is going to give me 13.93. Again, this is to two decimal place. Okay, let's take Alright, so let's take another example. You're supposed to calculate, so you're supposed to find M. This is a right angle triangle, so we apply the Pythagoras theorem. So from Pythagoras we can say that c squared plus m squared should be equal to 10 squared. Is that also? Alright, so 6 squared is 36 plus m squared should be equal to 100. Is that okay? Our goal is to find our m. So we'll take this one to the other side of the equal to sign. So we are going to have m squared is equal to 100 minus 36. So we have m squared is equal to 100 minus 36 will give us 64. Okay, will give us 64. So we are going to have m now will be equal to the square root of 64. So my m is equal to 8. Is that okay? Alright, so let's take another example. So we have this right angle triangle with hypotenuse 7 and one of the other side to be 3 and then the other to be x. We're supposed to find x, okay? So because this is a right angle triangle, quickly we just apply the Pythagoras theorem to find our x. So from Pythagoras we can say that 3 squared, we can say that 3 squared, this is too big, we can say that 3 squared plus s squared should be equal to 7 squared. Okay, so 3 squared will give us 9 plus s squared should be equal to 7 squared is 49. Is that also? Okay, so we are looking for x, so we carry this to the other side of the equation, of the equal to sign, sorry. So we are going to have s squared is equal to 49 minus 9. So s squared is equal to 49 minus 9 will give us 40. Okay, so then it means that our x is equal to the square root of 40. Now I want us to solve this without a calculator. Okay, so this is the same as the square root of 4 times 10. Okay, which can also be written as the square root of 4 times the square root of 10. Square root of 4 will give us 2 times the square root of 10 times the square root of what? Square root of 10, and that will give us 2 root of 10. 2 root 10. Okay. Alright, so let's look at this word problem. So we're saying that given the side of a square to be 5 centimeters, find the length of the diagonal. Okay, so the first place that we start from is to draw the diagram of the square. Remember, the square is a plane figure that has all sides, where all sides equal. So in this case, the side of the square was given. So the saying here is 5 centimeters, 5 centimeters, 5 centimeters, 5 centimeters. Okay, and we are supposed to find what? The length of the diagonal. So the diagonal is a line that is drawn from one corner to the other. Okay, and we realize that for the square, all the angles are right angled. Okay, all the angles are 90. So I can do this, can do something like this. Yes. Okay, this side is also 90. So you realize that after drawing the diagonal, we have 2 equal right angles, and our goal is to find the diagonal. Let me use the letter D. So let's bring out one of the triangle and see what is happening. So this is 5 centimeters and 5 centimeters. D, we are finding D. So because this is a right angle triangle, then we are going to apply the Pythagoras theorem to find out d. So from Pythagoras we can say that what d squared should be equal to what? 5 centimeters squared plus 5 centimeters squared. So d squared is equal to, this is 25 centimeter plus 25 centimeter. So d squared is going to be 25 plus 25 is going to give us 50 centimeter. D squared is equal to the square root of 50 centimeter. Again, I want us to solve this with a calculator, so this is the same as the square root of 25 times what? 2. This can also be written as the square root of 25 times the square root of 2. Okay. So the square root of 25 will give us 5 times the square root of 2. And this will give us 5 root 2. Okay. Centimeter. So that is the length of the diagonal.